Hello, in this demonstration I will show how to run visualizations in PySpark. Mostly this involves converting a PySpark DataFrame to a Pandas DataFrame and then using the Seaborn library to plot the data. So I typically do the calculations in a Spark DataFrame. For example, if I'm doing log of a column, I'll do the log in a Spark DataFrame. And after I've done whatever calculations I need to do, then I'll convert the overall data frame to pandas. And just a note about this, when you do two pandas in order to prepare for plotting, it moves the data from the cluster to the driver. And if you have a few thousand rows, it's no big deal. But if you have millions or billions of rows, this is not going to work. So in that case, if you have a lot of data, big data, then after you create your data frame in Spark and you've set up all the calculations you need, then you can sample the data frame. And then once you have that sample, a much smaller data set, then you can use two pandas, convert it to pandas, and then do your plotting. So what to plot with? Well, a notebook like Databricks notebook has some plotting built in, but I prefer to use Seaborn. You might use another library. And if you want to know more about Seaborn, then I recommend this tutorial, as well as there's a great YouTube channel, Kimberly Fessel's channel on using Seaborn. So I recommend you look at that. And Seaborn in particular has three kinds of plots that are the core. Distribution plot for plotting continuous functions, a categorical plot for plotting categorical or columns that have strings in them, and a relational plot where you're comparing two variables. And I'll demonstrate these. So the agenda for demonstration is just to download a data set, clean up the data set a little bit, and then plot using these three main functions from Seaborn. The kinds of plots you'll see will be like this distribution plot. This is housing data and prices of the housing data, or prices of wine. And on the left, you can use Databricks notebook function to plot the data. But as I said, I prefer to use Seaborn or some sort of other library, and that's what I'm going to demonstrate mostly. The Seaborn plots have a little bit more functionality than provided by the Databricks notebook. For example, there's a heat map and some other, here's a pair plot that I don't think is available in Databricks. I don't use it that much, the plotting function. And in terms of categorical plots, there's violin plot, for example, which I do not believe is in a lot of the notebooks. So let's go ahead and go forward with the demo and see if we can get this to work. Here I am in a Databricks notebook. Got a notebook set up for this demonstration for exploratory data analysis. What I'm doing first is just downloading some data. So I'll do wget to download some wine data. I'll read it in a Spark DataFrame using spark read.csv. And I'm going to drop some columns and combine some columns. In the end, I end up with one data frame. It turns out there's some issues in the data frame, so I wrote some user-defined functions, some UDFs, to determine if the values within a column are a number or if they're a string. And I go through and then work with the data frame, dropping some rows that have non-numeric columns, and same with bad strings. So after doing some data prep and including converting some of the columns to double to make sure that they're in the proper data type, I end up with, at the end, a data frame. Once I have that data frame, I can go ahead and display it. And Databricks has its display function like show. And you can see that there's a country column, a description of the wine, the number of points or evaluation of the wine. 100 is the top number of points. There's the price of the wine in dollars, the provenance, region, variety, and winery. So this is a bit of the data. We can see a summary of the data here. There's about 157,000 rows of data. In addition to the given columns, I went ahead and added a grade column just to add another categorical variable so that I could demonstrate more categorical variable plotting. And this is a simple one. It just based on the points, it converts that to a letter grade A, B, C, D, and so forth. This is just something I added. So this new column here, a grade column, which is a categorical column that converts the points through sort of a binning process here to A, B, C, or D. So that's the data. It's a Spark DataFrame. It's in data. And then next up is to convert that to Pandas so I can do some plotting. So just as a reminder, one of the things I can do if I have lots and lots of data is I can take my original rows, which were about 158,000, let's call it, and I can take a sampling of them, say maybe 25%, and then I'll get a lesser number of rows, and then I can work with that. Now that's what I would do if I had big data and had millions and millions of rows, but I don't. I got less than 200,000 rows, so it's not a big deal. So I'm going to go ahead and work with this PDF for Pandas DataFrames, which is based on my original Spark DataFrame, but I convert it to Pandas. So I'm going to go ahead and use some plotting library, the Seaborn library, and you can see the main functions it has: distribution plots, categorical plots, and a relational plot. So I'm going to import those libraries, including NumPy and the Matplotlib. And I'm going to start off with some distribution plots, this first set of plots. And I'm mainly just use the summary plotting function called displot. All right, so first I want to point out you can do this in a notebook that has some additional functionality like Databricks. And I simply take my Spark DataFrame and I'll select, say, the price column, and then I can do some plotting. And you can see down here at the bottom there's some menu items for plotting. So I can go ahead and do a histogram plot, and there's other plot options for each one of the plot types. I'm not going to go through this, but just be aware there's quite a bit of functionality built into the Databricks notebook. So I also want to point out here that you might think it's using all the data, but it's actually doing sampling as well. So while we have our Spark DataFrame and data, it's going to sample the first 1,000 rows and based on that do a plot. So you can also sort of work around this by getting the data yourself and maybe set a limit to it and then use a display. But by default, this plotting function is going to take the first 1,000 rows. Okay, so just something to note here. We've got sort of a long tail. Maybe we want to improve that a little bit. So one of the things we could do is pull in the Spark function for log and take our Spark DataFrame and log it and then plot that. And that's what this is. So we don't have quite as big a tail, and you can see the prices of the wine after it's been a log function applied to it. So once again, this is just your Spark, your Databricks DataFrame working on a Spark. Your Databricks notebook plotting the Spark DataFrame, and once again a sample of that. Okay, so we can also, instead of using the Databricks functionality, I just prefer to use the library of Seaborn. And so here it is abbreviated as SNS, and I'm going to use the distribution plot to demonstrate the distribution plot functions. And the way this works is you've got some data equal to a Pandas DataFrame, and then you can refer to columns here within the data frame and then other parameters based on the kind of plot you have. And then at the end here, you can set the title and other attributes. So in this case, we've got our data frame is a Pandas DataFrame, and the X's are going to be the price, and it turns out we have in that column the count of the price. So we have a histogram here, and you can see that once again we have the tail that we showed before. So just as a reminder, consider where the data is. I've been working with originally the Spark DataFrame, and I convert to Pandas. So I like to do the calculations in the Spark DataFrame, and then if I get a lot of data, sample it, and then convert to Pandas and plot it. So just to make this explicit, we start off with our Spark DataFrame. I'll do some calculation here. It's a log function, and then I'll convert it to Pandas, and then I'll plot that logs results. So that's one way of doing it, where I do the calculation in the Spark DataFrame over the cluster, and then I plot it. Next up, what you could do is do a sample. So I do the same thing. I do my calculation, but then I take a sample of the result, and I plot that. And just notice here, our scale is pretty high here, 25,000. And then on this one, it's 10,000. And it's not scaled as much because it doesn't have as much data, and it missed some of those data points. And so the scale is different. And that's because we don't have all the data. And one other thing you could do is go ahead and take all of your data to convert it to Pandas, assuming it's not, billions of rows. And then within Pandas, you can use the regular like NumPy functions, and here's a log function, and we can go ahead and plot the result here. I generally don't do this because it's going to be slower, especially if there's lots of data. So, all right, so what's next? So if I've got a distribution plot, what can I do with it? Well, one of the things I can use is once I've converted my data to Pandas, I can do the usual stuff with Pandas, and here's a filter. So we're going to only look at prices less than 200, and that gets rid of some of my tail here. Another thing I could do is log, which I already did that before. Oh, and I just want to point out, I think, yeah, this is just one more idea here. This is a kernel density estimation. That's this line that goes above our binned price data. Okay, so next up, I can do a little bit more. And one of the things I can do with Seaborn and these Python libraries is I can add a categorical information, and it's called hue. So here it is here, hue. And I've got a column. I just grabbed my data once again from PySpark, and I did some calculations of average price and points, and where those countries have over 1,000 reviews, and then I converted to Pandas. I pulled off the top 100 countries by the number of reviews they have, and then I plot that. I have some restriction on it. It has to be less than, the wine has to be less than $200 in price. And then I also have this hue, and the hue is going to be based on the country. So you can see that I have different colors based on the country. So this is the same old distribution plot, but it allows you to add some hues based on some categorical data. And you can see that there's looks like there's lots of wines that from the US where the price is, about $25. Okay, so I can start to sort of chop up this data, as I mentioned here, by category, but I can also use with the Seaborn, a facet grid, and that comes with the distribution plot. These main plots have a facet grid, and that allows you to specify what goes in a column and what goes in a row. And after preparing the data, first pull off the top 3 countries, and I pull off the top 3 varieties, and I use that in the following distribution plot to make sure I'm only plotting the varieties on the top 3 varieties, and of course the price is less than $200. All right, with that as the basis, then I'm going to go ahead and have columns that are by country. So it's hard to see here, but this first column I think is USA. It's hard to read. The next one, let's see, the last one is USA. This one I think is Italy, yeah, and this one is France. And I've zoomed in a little bit, but each column has a country in it. So if I look column-wise, I can see that this is all the USA wines. Okay, but what about by row? Well, by row, it's variety. So this is all Chardonnay in the first row, and Pinot Noir in the second row, and Cabernet in the third row. So this just allows you to pull out the data and compare it, and you can have rows and columns by some categories. So I have the category country for columns, and row for variety. And then you can even add in a third categorical information, grade. And I think I showed above that grade A is the best and B is the next best and so forth based on the points. And then you can see how those are distributed over the counts here. Sort of interesting that there's lots of A wines and fewer of the B and D wines. Okay, next up, just to show sort of variation on this, instead of price, I'm going to plot points and just, I changed my X to be points instead of price, and then I get a distribution graph of that. I can also do a joint distribution, so I can have two variables or two columns. And here I've got price and points, and price and points, and then you can see the distribution or the comparison of those here. You can also use a kernel density estimate to graph how the relationship between price and points. And you're just changing the kind here in order to get some of these, well, in this case, to get the kernel density estimate. Okay, next up, let's go on to, having done some distribution plots, let's go on to some relational plots. And the idea here is we're going to compare two continuous variables. So the first one you could do is, well, just an old scatter plot. So I've got price against points, and I'll do a scatter plot. And I can also use a relational plot to do essentially the same thing. Okay, next up, I can go ahead and do a pair plot, and it'll go through and do histograms along the diagonal. So points and points will be a histogram, price and price will be histogram. And otherwise, it does a comparative scatter plot. So let's say I have points versus price, and it'll do scatter plot there. Okay. Next up for comparison, correlation heat map. So let's go ahead and take our Pandas data and run a correlation over it. And it's going to look at all the continuous variables, which are just, in this case, price and points. And it'll compare, say, price and points, and the correlation is 0.43. The annotation allows you to take the correlation and write it onto the square. And you can see a scale here on the right, and the lighter numbers are higher correlation. Well, you can use that heat map to do other things besides correlation. For example, you could come up with one dimension, which would be the variety, another dimension, which would be the country, and then use the points in order, what did I do here, just to make sure I got it right? Yeah, points in order to have a scale. So if I compare a red blend with, say, Portugal, it has a light color here indicating a high score. So it allows me to see a heat map of variety versus country, where the heat is determined by the points. Okay, so we end up with country as an index. One of the columns here is variety, and the values are going to be the points. And once I have that, then I can plot that. So the things above is not all that interesting. It's just code to pull out the list of countries, the top 10 countries, pull out the top 10 varieties. And some of these figures, you can have a figure as part of the figure size as part of the parameter to the figure. But in the case of heat map, there's no such parameter. So instead, you'll have to use the plot figure to set the figure size. So if you don't have a parameter fig size in your plotting function, then you can use this idiom to specify the figure size. Okay, so next up is a hierarchical cluster map, or just cluster map. That's our comparison. And the idea is that we're going to take these varieties and then look along a number of dimensions, and so a number of columns. And in this case, you only got two continuous variables, and they are points and price. So based on those points and price, we're going to put the varieties of wine closer together. So if you look down one of these columns, like look at all these 87s. So presumably those are going to be pretty close. And in fact, here's an 18 and a 20. Those are very close. So if I think about comparing these 87s are the same and 18 or 20 pretty close, then the cluster map will go ahead and put these two together. And it indicates it with this line indicating that's a pairing. And that's called a dendrogram. And then once it has that pairing, then it'll look around for the other rows that seem to be closest. And next up seems to be this white blend. And then it adds that to another dendrogram in a hierarchical fashion. So this is done with the cluster map. And you just need to prepare it by coming up with some of your dimensions here, price and points. And you could have more dimensions, but I only had 2 continuous variables. And then the categorical thing that I'm trying to cluster, which is the variety. So that's going to be my index in my Pandas DataFrame. So once again, the preceding steps are just to pull out some of this data about the top, 15 of varieties, and coming up with the average points for these, because we have, it's not just one wine, it's lots of wines, and we're going to, for that variety, we're going to pick out the average. Anyway, once you've got that and in a data frame, and in this case, I'm picking out where the price is less than $200, then I can do a cluster map of that. In this case, the cluster map has this parameter fig size, and so I don't need to, go to the plot and set the figure size. Instead, I can just use the fig size as part of this function here. Okay, that's a cluster map. It's a hierarchical clustering of the varieties, in this case, varieties of wine. All right, next up, another comparison would be a regression where I have 2 columns or 2 variables I'm comparing, price and points. And I can use a regression plot, a reg plot. And in one dimension, I have the price, and the other the points. And then we've got a regression that goes through it. Because we've got lots of these outlier points, the regression doesn't look so good. So we can fix it up, and we'll do a few things at the same time. One is instead of the regression plot, we'll use the LM plot for linear model plot. And it does a little bit more than the regression plot. It has this facet grid and some other things to it. So we're going to use that. And in addition to that, I'm going to get rid of some of these outliers in price. So if you look at a little bit of the coding I have here, I'm going to only have prices less than 200. I do the same thing where I pull off some in varieties. In this case, I have 3 varieties. And I can, in addition to do the 3 varieties, are essentially running 3 different regressions. You can see the green line, the sort of salmon colored line, and I guess this is green and this one's blue. And you can see that it looks like as price goes up, the quality of Pinot Noir goes down, which is the opposite of what you expect. But in any case, this is a plot of that. And the points are associated with the particular hue or category. And so we've got, in this LM plot, we've got our data. Our X is our price. Our points is our Y. We've got this category for called hue. And then we can also set the markers here associated with these different categories or hues. And there's just a way to do that marker, and that's what this is all about. So if I've got 3 varieties, I'm going to pull off 3 markers so that they'll show up on this chart. All right, so next up, because LM plot has a facet grid, we can, instead of trying to plot everything all in one chart like we have here, we can pull it out separately. And we'll do the same thing we've done before with facet grids. We've got a column. So each column will be variety. This is the Chardonnay column. The next one is the Pinot Noir column, and so forth. And then the other part of our facet grid will be rows. And that's our country. So this row should be all France. Next row is all Italy, and so forth. So same thing again, I have my data. I'll pick out my X is my price, the Y is my points, and then I'll go ahead and have some facets for variety and country. And then it'll put my regression plots. And unfortunately, it looks like I only got a couple here that had enough data to be interesting. So, all right, anyway, that's that. Now let's go on to some categorical plots. These plots have a string, a categorical variable. Now you notice that we did refer to categorical variables in these preceding functions by hue. So I didn't use hue here, but I did by the facet grid, but here's the categorical hue for variety. Okay, and the categorical shows up also in the facet grid as the column and row. All right, so in any case, let's focus now on just categorical plots. And we'll pull off some country information where there's at least 1,000 reviews. We'll pull off the price and points and get some information about it. And here's simply categories, the counts of reviews by country. So here's the country, and then the count of reviews. And you can see USA has lots of reviews. Okay, next up, I can do the same thing here, but I can change my aspect to oriented horizontal instead of vertical. And I just allowed a few more countries by setting the minimum count of reviews to be over 20. So that gives me my same sort of plot, but oriented in horizontal fashion. Next up in the categorical plotting functionality is a violin plot. So it's a sort of a distribution plot, but it's under the categorical plotting, and I'll plot price, and you can see it's like a box plot, but it has a distribution over it, and you can see there's a long tail, so it's hard to see what's going on there. So a couple things we could do is we could filter using our Pandas DataFrame to say, let's only look at prices less than 200 to get rid of some of our high prices that are part of our tail. Or what we could also do is do a log. And so we logged in this case using the PySpark DataFrame, do the log and then convert to pandas, and then plot the violin plot of that log. Okay, now this is just one. This is just one violin plot. What we could do is break it out by country, for example. So that's what's done next. And in this case, we're going to plot the country as our X, the price is our Y, and the kind of plot is violin plot. And we'll put this all in one plot here. So different countries down to USA and then the prices. So once again, the preceding code is just to pull out the proper data. All right, so now we can go on and add a little bit more information to this plot above. And just for fun, instead of violin plot, I'm going to change the kind to be box plot. So now I've got my countries across the x-axis. So same as before, country and then price for y, box plot instead of violin plot. And now I can add a little bit of categorical information, hue. And I'll do the hue for the variety. So you can see across Portugal, for example, the different hues starting on the left with the red and ending on the right with the Pinot Noir. So that adds in, hues with my box plot. Right now, let's go on to, instead of have it all in one chart, let's pull it out using a facet grid. So same sort of data here. X is my country, Y is my price, box plot. And now columns will be the variety. So in this first column, I have the Cabernets, and the second column, the Chardonnays, and so forth. And that's all I got in that plot. So that's just one. I just have columns for my facet grid. But I could go on. Let's add more. There can be more. So same idea here. The country is my X in this case. Price is my Y. I'm going to do a box plot. I'm going to do rows. The first row is going to be my A grade. The second row is my B grade. And then I'm going to again use the variety for the column. So you can see here, here's all your A wines. And the variety, the first column is the red, the second is Chardonnay, and so forth. And then you can see how the price varies. And if I go down, I thought it was interesting, it seems like the prices are pretty, sort of stable in these higher quality wines. But then you go to the lower quality wines, the C, you get a smaller price range, but a lot of outliers. So a lot of variability in those prices. All right, so that's it. That's a whirlwind tour of going through a variety of types of plots. We went through a distribution plot, relational plots, and categorical plots of our PySpark data. So it demonstrated and pointed out how to get your PySpark DataFrame data through sample or copying them all to Pandas. And once you have it in Pandas, then you can plot them. So I hope that was helpful and hope it works for you.